Hello everyone, I am Sneha, Assistant Professor, Department of ECE, Siddhartha Academy of Higher Education, deemed to be university. Now let us discuss about sorting. So this slide introduces the topic of sorting, defining it as a process of arranging array elements in a specific order, either ascending or descending. Sorting improves data retrieval speed, making searches and analysis faster. Stable sorting algorithms maintain the order of equal elements, which is important in applications like databases. Sorting is used in database management, artificial intelligence, data processing, and even real life scenarios like arranging books in a library. So, sorting is of three types: insertion sort, selection sort, and bubble sort. Now, let us see the first type of sorting, which is insertion sorting. So as you can see on the slide, insertion sort algorithm arranges a list of elements. In this algorithm, every iteration moves an element from unsorted to sorted portion until all the elements are sorted in the list. This algorithm is not suitable for the large data set. So now let us see how an insertion sort works. So let us start with the array, which is the first line. Here you can see on the first line the array is 4 3 2 10 12 1 5 and 6. So here the first element 4 is already sorted. Move the second element 3. Now compare 3 and 4, swap them. So after swapping, the new array will be, see the third line, 3 4 2 10 12 1 5 and 6. Now coming to next step, consider element 2, compare with 4 and swap. So now the new array will be 3 2 4 10 12 1 5 6. Then compare 3 and 2, swap them. Now the new array is 2 3 4 10 12 1 5 6. Next consider element 10. Since it is already in the correct position, no swap is required. Next consider element 12. It is already in the correct position, so no swapping. Consider element 1. Compare with 12. Now swap. Now the array will be 2 3 4 10 1 12 5 6. Then with 10, do again swapping. Then with 4, again swapping. Then with 3, again swapping. Finally swap with 2. Now the final array will be 1 2 3 4 10 12 5 and 6. So now 1 to 12 all the elements are sorted and the last remaining numbers are 5 and 6. Consider element 5. See on the slide, it is third line from last. Consider element 5, compare with 12, swap. Then with 10, again swap. So now the final array will be 1 2 3 4 5 10 12 and 6. Now only the last number 6 is remained for swapping. Now compare that with 12, swap, and then compare with 10, again swap. Now the final sorted array is 1 2 3 4 5 6 10 and 12, which is the last line of the slide. This is about insertion sort. So coming to next one, selection sort. So selection sort algorithm, here the first element in the list is selected and it is compared with all the remaining elements in the list. If any element is smaller than the selected element, then the both are swapped. So the first position is filled with smallest element. This procedure is repeated until the entire list is sorted. So now let us see how the selection sort works. First, consider the array 12, 29, 25, 8, 32, 17 and 40. First, find smallest element in the array. First iteration looks for the smallest element. So here in the array taken, the smallest element is 8. Swap 8 with the first element 12. So now the resultant array will be 8, 29, 25, 12, 32, 17 and 40, which is third line, which is the third line now. Next, find smallest element in the remaining part of the array. Start from index 1 to the end. Why am I telling start from index 1? Because index 0 has 8, which is already sorted. So you have to start the sorting from index 1. So now the smallest element is 12. Swap 12 with the second element 29. Now the resultant array is 8, 12, 25, 29, 32, 17 and 40. So this is the last line of the array. Now let us continue the process. It is in the next slide. Now find smallest element in the remaining part from index 2 onwards. Smallest element is 17. Swap 17 with 25. Resultant array will be 8, 12, 17, 29, 32, 25 and 40. Repeat for remaining part from index 3 onwards. Smallest element is 25. Swap 25 with 29. Resultant array is 8, 12, 17, 25, 32, 29 and 40. Now again continue sorting. From index 4 onwards, smallest element is 29. Swap 29 with 32. Now the resultant array is 8, 12, 17, 25, 29, 32 and 40. So the last two numbers 32 and 40 are already are already sorted, so no need to change their positions. Next is bubble sorting. So bubble sort is the simplest sorting algorithm if you compare among the three. It always arranges the data in descending order. Bubble sort algorithm is not suitable for the huge data set. Bubble sort algorithm compares the two items at a time and swaps them if they are in the wrong order. So the iteration is repeated until no swapping are needed. So which means list is sorted. Now let us see an example how a bubble sort works. So if you see the slide, they have taken an array 40, 50, 30, 20, 10. So there it is an array of total 5 numbers. So I have taken a of 5. A of 5 means the 5 indicates the size of the array. Okay. So now let us see the iteration 1. Here if you see a of 0, a of 1, a of 2, a of 3, a of 4, the 0, 1, 2, 3, 5 are indexes. 0, 1, 2, 3, 4 are indexes. So any index of an array will start with 0, not 1. Okay. Compare a of 0 40 and a of 1 50. So as 40 is less than 50, no swapping is required. So the array will remain same 40, 50, 30, 20 and 10. Next step, compare a of 1 50 and a of 2 30. As 50 is greater than 30, swapping is required. So now the array will be 40, 30, 50, 20 and 10. Next one. Compare a of 250 and a of 320. So here again 50 is greater than 20. So swapping is required. So the now array will be 40, 30, 20, 50 and 10. Step 4. Compare A of 3, 50 and A of 4, 10. As 50 is greater than 10, again we need to do swapping. So now the array will be 40, 30, 20, 10 and 50. So after iteration 1, the largest element 50 bubbles to end. Okay, this is about iteration 1. Next, let us see iteration 2. Compare A of 0, 40, A of 1, 30. 40 greater than 30, swapping is required. Now the array will be 30, 40, 20, 10 and 50. Next step, compare A of 1, 40 and A of 2, 20. So 40 greater than 20, swapping is required. Now the array will be 30, 20, 40, 10 and 50. Next, compare A of 2, 40 and A of 3, 10. So here 40 greater than 10. Again swapping is required. Now the array will be 30, 20, 10, 40 and 50. No need to compare last element as it is already sorted. Next, iteration 3. Compare A of 0, 30, A of 1, 20. 30 is greater than 20, so swapping is required. 20, 30, 10, 40, 50 is a new array. Next, compare A of 1, 30 and A of 2, 10. As 30 is greater than 10, swapping must be followed. So the now array will be 20, 10, 30, 40 and 50. Next, compare A of 2, 30 and A of 3, 40. As 30 is less than 40, no swapping. Now the array will be 20, 10, 30, 40 and 50. Now 40 and 50 are already swapped. Let us see about iteration 4. Compare A of 0, 20, A of 1, 10. As 20 is greater than 10, swapping must be followed. So now the array is 10, 20, 30, 40, 50. Step 2. Compare A of 120 and A of 230. As 20 is less than 30, no swapping. 10, 20, 30, 40, 50 is the final array. So now the array is fully sorted.